Hello, in this session we will study about a single phase SCR fed RLE circuit. These circuits are equivalent to DC motor circuits. If you are new to this channel, subscribe to Tech Talks by clicking the red button in the right hand side corner below and hit the bell icon to stay updated. Subscribe to Tech Talks and hit the bell icon to stay updated with latest and coolest engineering technology. In step 1, first of all we will draw the circuit diagram. It is a thyristorized rectifier. So these are 4 thyristors. Single phase thyristorized rectifier. It consists of an AC source, and the load that is connected is RLE. So this is R, L, and this is E with an RLE load. And whatever is given in question is that this is 230 volt. Remember that this is RMS voltage, 50 Hertz. The value of R is 0.5 ohm. Value of L is 5 millihenry. And value of E is 130 volt. We try to draw the waveforms. So suppose this is Vs with respect to omega t, and our DC voltage, E voltage, this voltage is 130 volt. The peak of this value is what? The peak of this value is 230 root 2. That is 230 root 2 volts. That is equals to 325 volt. So our DC voltage is 130 volt. 130 volt means it is lying almost here. So we get some values over here, that is this point where the DC voltage and the AC voltage intersects. This height is where after which firing should be done. Why is this so? Because if you zoom this part, this point, if you zoom this part, if you fire it before this angle, then your DC voltage is predominant. If you fire it after this angle, then your AC voltage is predominant, but you are losing some much of voltage, output voltage. So at this point, if you fire it, then you will be getting maximum voltage. So in question what is asked is that how to find out this voltage. So let us draw the waveform if this happens. So waveform, if it is fired over here, then how it would look like? It would look like here also, here firing will be done. This will be our B output. In this situation, how the current would look like? The current would look like, from here it will start, it will go till here, and then again it will fall down. This height and this height will be equal. Again it will start, go till this height, and it will fall down. the average value of this current is given in question, that is equal to 10 ampere. So this is the current that is flowing in this path, and this voltage will be appearing over here. So we need to find out what is this angle at which we should start firing, that is firing angle delay. You need to find out that what is this V output, that is this voltage. This voltage equal to what? If this is alpha, then this is pi plus alpha. Then this is equal to Vm sine omega t d omega t integration of alpha to pi plus alpha divided by 1 by pi. If you integrate this one, then you will get it is coming as 2 Vm by pi cos alpha. Then if we apply KVL in this path, then we will get what? We will get VO equal to IOR plus L DIO dt plus E. Now since I is continuous and equal to 10 volt, then this di dt is almost equal to 0. So we are left with this equation. So here 2 Vm by pi cos alpha equal to 10 into 0.5 plus 130. So this is equal to 2 into 230 root 2 by pi cos alpha 135. From here, if you calculate what is alpha, then it will come as 49.31 degree. So what does it mean? It means that at 49.31 degree, the DC voltage, that is E, and the AC voltage, that is sine wave, are meeting with each other. So at that point we should fire this thyristor. The next part of the problem tells that E is connected in reverse order. So here we will go to straight away to this formula, that is V0 equal to I0R plus minus E. So here it is equal to Vm by pi cos alpha is equal to 10 into 0.5 minus 130. So this is equals to 2 into 230 root 2 by pi cos alpha minus 125. From here, if you calculate alpha, it will come as 127.13 degree. That means if you fire after this part, then your firing will be valid. So whatever was asked in the question, that if what is the firing angle delay for one direction of E, this is the answer. For the other direction of E, this is the answer. Okay, if you like this video, do like, and don't forget to comment if you don't understand anything or what requirement you have. Do subscribe and hit the like button for further notification. Thank you. Comment below about how you like this video. Check out the links in the description box about more such videos. Do click the like button if you like the video. If you are new to this channel, subscribe Tech Talks and don't forget to hit the bell icon.